Hi, my name is Tiago. I am a PhD student at the University of Auckland, and this work is with my supervisor, Dr. Mohan from the University of Birmingham. It is about how to construct disambiguation queries in the context of the human-robot interaction. The motivation for this work is that humans may pose ambiguous queries in the requests. So, look at the arrangement of objects in the figure. The human may request the robot to move the green ball to the top of the yellow object, which is obviously an ambiguous query since you have 4 yellow objects in the figure. So, in this work, we use the agent's knowledge to reduce the effort in disambiguating. So, the objective of this work is design a disambiguation system able to construct questions most likely to address such ambiguities. This system is built on the top of an architecture that integrates monotonic logical reasoning with common sense knowledge and learning from a small number of samples, and that provide explanatory description for the robot's decisions and beliefs. So the knowledge interactively learned in the form of symbolic rules are used in our system to help improve the quality of disambiguation queries. And for the disambiguation system to work, we need to devise a rules trace algorithm to retrieve the relevant information from the knowledge base. Here you have the overall representation of our architecture that is divided in 3 parts by the blue dashed lines. To the right, you have the 2 blocks that are responsible for incrementally learning unknown axioms from labeled images and features extracted from these images. These features are spatial relations between objects, size, shape, and colors of these objects. Such learned axioms are then recorded in the knowledge base for future reasoning and for answering questions. To the left, you have the 2 blocks that are responsible for the interaction with humans. So these blocks receive the human utterance, selects thus the part of the speech that are relevant, and use that for retrieving the axioms in the knowledge base that can help to answer these questions. In the middle, you have your knowledge base that is represented by means of symbolic rules in ASP program. ASP is able to do common sense reasoning with incomplete domain knowledge. In the middle, the top, you have our disambiguation system that will be detailed in the next slide. The disambiguation algorithm uses 3 heuristics, namely the unambiguity, human confusion, and features rank. The unambiguity tries to minimize the ambiguity in the human response after the robot poses the disambiguation query. The human confusion tries to minimize the complexity of the disambiguation questions by using the minimum number of features in it. The features rank tries to use features that are preferred to humans. The algorithm also uses the related knowledge in the robot's knowledge base for improving these disambiguation queries. In this slide, you have our experimental results. As a baseline, we randomly choose features to compose the disambiguation queries one by one. As we can see in the figure, our proposed method in yellow use just one interaction for disambiguating, whereas the baseline in green needs 2 to 3.5 more interactions. And at the bottom you measure the accuracy of the human response after the disambiguation query. And as you can see, the baseline is in gray, is improved when we use the proposed approach in red, and the accuracy is further improved if you use the robot knowledge in brown. In conclusion, in this work, we integrate a disambiguation algorithm to a system composed by reasoning with common sense knowledge, learning from data, and that provide explanatory description for the robot decisions and beliefs. For that, we also have to devise a tracing beliefs algorithm to retrieve the relevant rules from the knowledge base. As future work, we want to explore the interplay between reasoning and learning for explaining decision and beliefs in more complex domains. For more details about this work, please see the paper, and I am available for any questions you may have. Thank you.